Hey everyone, and welcome to Building SaaS on AWS. My name is Gunnar Grosch. I am a developer advocate here at AWS. And if you are building or planning to build a SaaS product, this is the show for you. What we do here every other week is that I bring on SaaS experts to talk about SaaS specific topics so you can learn more about building SaaS on AWS. And this week, I'm joined by Woon Jung. He's a co-founder and CTO at Clumio, and also by Anthony Fiore. He's a solutions architect at AWS. Welcome to the show, guys.
Hello.
Thanks, Gunnar.
So, Woon, let's start off with you. A quick introduction. I already mentioned that you're a co-founder and CTO at Clumio.
Yep. My name is Woon Jung. I'm a co-founder and CTO at Clumio. If you ask me what I do, it changes from quarter to quarter. But I do spend significant amount of my time and actually on the R&D side of the house and designing and implementing various subsystems within our service. Prior to Clumio, I actually spent roughly 15 years again as a software developer. That's something that I love to do. Started my career back at VMware. I was an early VM kernel engineer, where I had to work on things like booting up hardware all the way from implementing system calls. Then I actually spent a good amount of time in a company called Pernix Data, where I worked on the IO stack. And then after that, started Clumio, and then now I'm actually building services on top of AWS API. As you can see, I've been around. It went from implementing very low-level stuff, kind of parsing BIOS, all the way to now AWS stuff.
Excited to have you here, Woon. Anthony, a brief introduction.
Hey everyone, Anthony Fiore. So I'm a solutions architect at AWS. I've been here for almost 4 years now. Most of my time is spent helping customers and partners build on AWS and just help them really help them get the most out of our AWS services. And I've had the pleasure of working with Woon since, now was it Woon, like 2019, right? So it's been a great ride. So great to be here.
Great to have you here as well, Anthony. And if you have watched the show, you already know this. If you haven't, well, this show is meant to be quite interactive. So if you have any questions, any comments throughout the show, just post them in the chat and we'll do our best, or I say we, but Anthony and Woon are going to answer those questions for you. And I'm excited for this episode because we're going to dive deep on what Clumio does and how Clumio is building SaaS on AWS. So let's start out with Clumio. So tell us a bit about what Clumio does, Woon.
Okay, so Clumio is a backup as a service company. We basically provide our customers a way to identify their assets in their AWS environments. By asset, I mean things like EBS volumes, EC2s, RDS, typical data sources in AWS. So we allow them to discover what they have, and then also kind of profile them based on the risk profiles, whether you're protected, not protected. And then if you're not protected, through basically a policy engine, we allow them to actually go ahead and protect those assets and actually perform backups. And we actually provide all that as a service. So we allow the customers to actually make a copy of the data on their AWS accounts, to make an air gap copy in Clumio, so that in the event of, let's say, an AWS account compromises or ransomware attacks or accidental data losses, you can actually restore that data from Clumio.
And in previous episodes of this show, we've looked at different reference architectures. We've also had other guests on to talk about their implementation of SaaS. And what would you say differentiates Clumio from other, in the way you build SaaS?
Okay, so one of the difference I would say is that to begin with, one of the differences is that we did not have any baggage, so to say. So we did not start from an on-prem where we did not have a software that was running inside a box that we had to retrofit it. But instead, from day one, we actually started building a service in the cloud, like cloud native, and that's what we wanted to do. So essentially, one of the differentiator is that it is a software it is a service, actually, because that's what I tell everybody that joins the team, that guys, we're not selling software, but we are actually selling a service. So we actually designed it from the ground up, cloud native and as a service, which then, again, it seems easy, but it's actually quite complicated, because when you're actually selling a software or shipping a software, you're not only shipping the software, but you're also shipping the complexity along with it, because traditionally it is the customer who actually manages all that for you. But once you actually make it into a service, it means that you're actually taking that complexity to yourself. So the platform has to be able to handle all that complexity, meaning in terms of monitoring, upgrading, and actually provide a true service. And I think that's kind of the key differentiator as compared to anything else. On top of that, the ability to actually provide a very comprehensive report in terms of compliance and what's protected and what's not, that's quite unique. And ability to actually provide you an air gap copy, because we actually do keep a copy outside of your premises, so that in the case of compromises, you always have access to the data.
To maybe get a better understanding, can we have a look at your service, what it looks like, and how customers actually use it?
Yeah, sure we can. So let me quickly share the homepage. Oops, I want to stay logged in. So essentially, this is what the customers see whenever they log into our service. It is basically a tool that allows you to get a general idea of whether you're protected or underprotected, basically, and different dashboards that allows you to discover. And we also provide you scores in terms of what your status is right now. We provide things like audit log, task reporting, and then obviously from there, we allow you to actually perform backups. We do support things like AWS, Microsoft 365, and VMware on AWS, right? So basically, at a glimpse, this is what the customers would manage. And then, but this is kind of the face of what the customers see. But just to give you an example, because I can go on and on, just talk about what Clumio does, but I'm sure that this is not that talk. But just to get to the point, essentially, if I were to go ahead and click something like a task list, so essentially, everything that happens within Clumio is basically has a task associated with it, whether that is a backup, whether that is a restore, or data verification, whatever that might be, right? There's a task associated with it. And this UI is what our customer sees. However, behind the scene, what we see in Clumio is actually very different, because at the end of the day, this is a service and it is something that we need to support day in, day out. What that means is that, for example, if a backup were to fail, basically our support team or Clumio should be the very first one that identifies the failure. And then without the customer intervening, we should be able to go ahead and identify it and actually go ahead and proactively fix it. For us to be able to do that, essentially, we built an internal tool that we actually call debugger. So if I show you, so if I actually go ahead and copy that task ID, let's say I just copy that, 1089, and this is the view. So if I actually copy that task ID, live demo, okay, now showed up. So essentially what we do is, this is how that task 1089 looks like internally. And this is what our developers looks at. This is what our support team will look at. Anything that we do, whether that is backup, restore, this is how it looks. Well, one thing to call out, this is my demo cluster. I intentionally kind of, obfuscated the step name. So in order to kind of protect IP. But as you can see, every single step does one thing in the process of backup. So this entire workflow is a single EBS file restore, I believe. That's what the task ID that I copied. And then essentially green means that the step has succeeded. If anything were to fail, that bubble will actually go to red. If it is in progress, it would actually be in yellow. If this step is successful, obviously this arrow tells you that this is the next step that it should be executed. And if for whatever reason, if this step fails, then the red arrow is what is taken. And if the user decides to cancel that task 1089, the purple line is what's taken. So essentially the beauty of this is that when a task ID over here fails from the customer's perspective, our support team will actually get a Slack message. The Slack message will contain a link to this page. and the support team will open it. And as soon as they open, they will actually see one of the bubbles being red. And when that happens, it's actually pretty clear how to go ahead and debug it, namely because you know all of the previous steps that was executed before that error, you know all the inputs, and therefore it's actually pretty straightforward for you to go ahead and debug it. It's actually very different because, as I said earlier, if you want to build a service, you have to be able to support these things very rapidly. In a traditional way, if for every error, your support team needs to spend half an hour kind of combing through different log files to identify the problem, that's not going to scale. When an error happens, you should be able to identify it within minutes and be able to actually go ahead and patch that. I mean, obviously, we'll come back more to this diagram. We'll keep talking about it, but that's kind of a high level what's happening in Clumio.
And I think many of the builders out there, they are quite familiar with workflows, state machines, for instance, AWS Step Functions as well, and having this viewer. Can you just briefly mention what a typical step in this workflow could be? What does it actually mean? What is happening in a typical step?
Right. Yeah. Again, sorry, I had to obfuscate the name, so it's not very clear. They're all AWS demo. It's pretty boring. But to get to the point, essentially, it is a unit of work that happens. So essentially, it could be executing within a Docker container, or it could actually be executing within a Lambda function. So every bubble, in most cases, is a Lambda function that gets triggered. And then that Lambda function will perform a specific action, like look up. In the case of let's say incremental backups, it means that there's a parent backup. It means that we have to look up the information about the parent backup. That could be one thing. A step could be also a way to process. Let's say, given a terabyte disk, we chunk the terabyte in small pieces. Let's say in 100 megabyte pieces, and one Lambda function could actually be processing the 100 gigabyte region within that 1 terabyte disk. So it could actually be doing different things, but you actually code it up this way. Moreover, some of the Lambda functions can actually be executed across accounts. So I mean, we'll touch that a little later, but some of these things actually do cross account boundaries as well.
So we have a question
for you.
Yeah, go ahead, Anthony, first.
Sorry. So you mentioned containers and Lambda functions. Just out of curiosity, there any decision tree for you in terms of, hey, I want to put this step in the workflow. I want this to be a Lambda function, or I want this to be a container. Is it something where I know this is going to persist? This is a task that needs to persist for greater than 15 minutes. Therefore, it's a container, or is it more than that? Is there anything you can share about, really more for guidance for the audience?
Right, got it. So yeah, some of the things that we use is that if it's a very short operation, like kind of looking up a database type of thing, then we actually tend to use the container because it's up and running, and it's basically, then that's what we use. But if it is anything that is meaningful, that it would actually run for, let's say, a 10-minute period or 5 minutes, then we actually try to leverage Lambda function as much as possible. And then the other aspect that we do consider is kind of the scalability. So like in the previous example, if I'm chunking up 1 terabyte disk in 100 gigabyte regions, it means that I'm actually forking off that work into many Lambda functions. It means that I need to be able to scale out very quickly. In that case, Lambda is the perfect use case where we actually use Lambda to burst out very quickly and process all that disk concurrently very fast, and then kind of join them together.
And I think that's quite interesting what you mentioned there on using containers that are already running for these very brief, quick tasks that many perhaps would instead use AWS Lambda for, and instead have those more 10-minute tasks running in containers. So I think that's an interesting way of how you've built your product. So there was a question in the chat that I wanted to bring up, more around Clumio as for customers. Which are the customers? I would say the question basically is it for other SaaS providers, or is it meant for any builder out there?
Oh, so essentially, well, first of all, Clumio is not a monitoring tool, or for that matter, not only a monitoring tool. We're a backup as a service company. We will actually monitor the state of your assets in terms of data protection, how well you're doing. That's what we monitor. But then the main purpose of Clumio is that we allow you to actually back up those data sources into Clumio. Now, now answer the second part of the question is who's our customer? I would say our customers will be the large enterprises where they bring their workloads to AWS and they run that workload in AWS. And then now, because the data sits in AWS, it doesn't mean that you don't need to protect it, right? Backup is required. And then those are the customers that they will actually leverage Clumio, both to understand what is the current state of backup protection on their account, as well as to actually take action and protect those assets.
That's a good answer. Thank you. So going back a bit to Clumio, how it started out, you mentioned that you didn't have any baggage. You were able to start, basically build it on AWS straight away. When you started building that, when did you feel that you were ready for your MVP to actually have a product for customers to use? And how did you know that you were ready to actually have that product ready for customers?
When I was, so actually that's a very interesting question. One of the things that what we wanted to make sure is that obviously the product, that's what the MVP stands for. Obviously the MVP needs to be decided with the product team. So once the MVP was designed, we make sure that the functionality wise was working. But then more importantly, what we wanted to have ready is the ability, or the platform, the ability to actually iterate quickly. So essentially, when it comes to either cost optimization, performance, we wanted to have the ability and then the platform that if something were to happen, for instance, if I find a bug in one of the Lambda functions, I want to have all the platforms ready where I can actually go ahead and update a single Lambda function so we can actually quickly iterate. So the short answer will be, once I knew that the basic service is working, and then, but I had the platform behind the scene where I could actually quickly change things and iterate, that's when we knew that we were ready.
And time-wise, what are we talking about then? What year are we at then?
It took us a long time, to be honest, right? Because it's also related to the MVP. Because if I tell you a backup is something that has been around forever, right? Forever. So what that means is that the MVP is also somewhat big. It's a large surface area that we need to cover. So that was one reason that it took us a long time. I would say that it actually took us close to 2 years, 1.5 years to 2 years to get to the point where the basic stuff was working. On top of that, we were sure that at least from the backend and CI/CD testing and all that, backend stuff, we're ready to actually go and, iterate quickly.
So going back a bit to the architecture, or touching more on that, we've mentioned that you're using AWS Lambda functions, but also that you're using containers. But I know that Woon, you have, I think, what's called Woon's army of Lambda functions. Isn't that right?
Yeah.
So do you consider this architecture mainly serverless?
Yes, so it is mainly serverless. So all of this step that I show you here, they're all basically, majority of this is Lambda function that gets executed. So basically, in a way, this is like a programming language that, in a traditional sense, like if I can give you an analogy with this, right? So, I also come from the kernel domain, right? So if you think about it in the traditional world, what's your favorite programming language? C? Okay, well, you write the C app, and then you would actually compile it, and that gives you a binary. And that binary gets executed, in the CPU, and then the states are actually put in memory. And that's kind of your, traditional apps works. And obviously they have IO and stuff like that. So if you bring that concept into what we call the workflow, it's actually every developer, when they actually design a backup restore, whatever that might be, right? Any cloud SaaS application, they would actually write those individual Lambda functions, and they would actually write a plan, like how it basically, the step A connects to step B, what are the differences. I don't know if I'm showing you here, but there's things like, this thing here would actually be a subroutine that you can actually call in. So, okay, I'm logged in. See, this is like a subroutine that gets called. So it's actually, and then we have if steps that allows you to say, if this, then do that type of thing. So essentially, it's a small programming language that we ended up building. So I'm actually getting to this is because yes, everybody calls. By the way, I don't like the Woon's Army of Lambda because I feel like that gives me too much credit. But the thing is, like, fine, you have a ton of Lambda function, but what's more important is that you need to have the platform behind the scene that actually ties all of these Lambdas together, because you just cannot just let them all loose, do whatever that they want, but you have to have the proper framework, like the if steps. How do you fork out 1,000 Lambda function and wait until all thousands are done and then join them, and then after that take the next step? So that's kind of how we actually go ahead and build that. So it's not just the army of Lambda, but it's more about what actually controls all those thousands or 2,000 Lambda functions. And if one fails, how do you retry them? Basically, things does fail, right? So then what happens? Like if this steps here starts executing and then it fails, like what happens? Do we retry? All that stuff needs to happen. And if the workflow has a bug, how do you fix that? If a specific Lambda function has a bug, how do you replace that? What happens to the versioning? And all that stuff needs to be put in place. And then the army of Lambda starts making sense.
So how do you keep track of that then? Did you say 2,000 Lambda functions?
Yeah.
Is the workflow view the way for you to track what each Lambda function does? Or do you have another way of keeping track of 2,000 Lambda functions?
So the workflow is one way. I'm trying to find an example out here. I think I had it. The problem is that I ended up obfuscating all the names to the point that I also don't know what what every step does, but we can click around. But there's definitely one step here where you would actually see a triangle where it actually spins up a lot of bubbles. And then the reverse triangle where all of these bubbles join. And that's when I know that all those 1,000 Lambda functions completed. So essentially, a typical example is if an EC2 has 5 EBS volumes, then we will actually take a snapshot of the entire EC2 at the very top. Then we fork out and we initiate the backup for every one of those 5 EBS volume. That will be a fork step. And within that, we actually go ahead and split the disk into very, very small areas so that we can actually in parallel actually back up, the 100 gigabytes or the terabyte disk, and we chunk them out and do them all concurrently within the Lambda. But then it is really the platform that holds it all together so that we can actually burst out and process all of these things and still have a tight control of what's happening in the system, rather than, firing up 1,000 Lambdas and maybe, 999 of them work, but then one of them fail, and which one? And then what happens to that? Why did it fail? Do you retry? All that thing, you need to control them. Otherwise, it's just basically, it doesn't work otherwise.
And how granular is this on the customer side? How much of the workflow is visible for them?
Right now, I'll show you. This is it. That one number.
Okay.
This is all complexity that we take it up, and this is how we can actually allow our support team to troubleshoot anything within a minute or two when an error happens.
And that's very AWS-like, right? In terms of just taking that undifferentiated heavy lifting of managing backup, right? Because as a former backup admin in my former life, I had to worry about things like this, right? When backups failed and figuring out what tape is bad or what went wrong. And here it's just for a customer, it's very, very simple. They don't have to worry about that complexity. They leave that up to Clumio, which I think is quite nice. Woon, if you wouldn't mind, to kind of merge this with the MVP discussion. I mean, how does what we're seeing today? How does that differ from kind of where you were at launch? Just to kind of give the viewers kind of an idea of how this has evolved over time. How the army has grown, so to speak.
Yeah.
Sorry, I keep going back to that. So.
No, it's okay. No, I think now it's official. So, no, basically when we first started it, we had the workflow in place, from the very beginning, because that's something that we're not willing to compromise. Get the platform ready to iterate quickly. However, some of the steps would have been a little longer running than we wanted to. Some of the steps we're doing a little more work than what we wanted to, because what happens is that if an error happens in a step that executes for 5 minutes and it crashes, that's fine. We will actually redo those 5 minutes. But then if you run something for 2 hours and it crashes, I don't know, in the hour, 1 hour and 59 minutes, that's basically, you don't want to retry the whole thing. There's a lot of wasted resource. To go back where we started, we have a lot of those things, like, bigger chunks that we wanted to. And over time, we actually break those apart. In some cases, I tell you one example, I think you were very intimate with this example, Anthony. Way back when we actually decided to implement EBS backups, for example, we were not splitting the disk into 100 gigabyte regions. If the customer had a terabyte disk, we would actually go ahead and back up the 1 terabyte in a single step. Obviously, the single step wouldn't be a Lambda because processing 1 terabyte wouldn't finish in 15 minutes. That tells you that we had an EC2 instance running in the customer account, which then means VPC on the customer account. The more stuff that we deploy in the customer environment, the more things that they need to manage it, which is a big no-no for us. We want to take that complexity to ourselves. I think a couple of years ago, AWS announced the Direct API, which allowed us to directly read from snapshots through IAM roles. What that allow us to do is to actually then ditch the EC2, ditch the VPC on the customer accounts. We actually put a single IAM role, and then we actually access all the data through API. But at the same time, that actually allowed us to actually break that single giant EC2 that used to process the entire 1 terabyte into hundreds of Lambda functions that they will actually each process 100 gigabytes each concurrently. That means that, if something fails in the middle, that's okay. I'm just going to redo that 100 gigabytes, and I'm not redoing the entire 1 terabytes, right?
Yeah, it's almost like I hate to call it a monolith, which, but it's like a monolith to microservice play almost, right? Because that you don't have to redo that entire EC2 process, like you were saying. And I think what was also interesting is when we were having those conversations, you were also pretty laser focused on customer and cost, right? There's a cost involved to EC2 instance, there's a cost involved to Lambda functions. So there's some differences there too. So it was inspiring to see that how that evolved.
It's all about optimization. It's all about cost optimization, performance optimization. Make sure you break it up so that you can actually become more fault tolerant.
And you're not doing quarterly updates, right? You're doing, you're not doing.
Yeah, every week we push. Every week push. That's what we do. And then for that matter, if we do find a hot patch, like in the sense that a customer finds a bug in a particular Lambda function, we actually go ahead and patch that one Lambda function. So we don't have to go ahead and retest all of these 200 steps that comprises that builds the backup, but instead we go ahead and unit test and function test that one step, and we actually go ahead and rip and replace that one step within the entire workflow. So it's pretty powerful in that sense. Like, essentially what happens is like the workflow plan is your binary. Now going to that app, right? It's your binary, right? Because it tells you execute line 1, execute line 2, if statement, execute the other line, right? That's what we do. So then now the end result of every step is actually you store them in memory or you store them in the register in the old traditional CPU, right? But in our case, the results of every step is actually stored in a DynamoDB table, right? So then let's say I execute step A. Once that step A is complete, the result of that step A is actually stored in a DynamoDB table. And we send a queue message through SQS and then to notify that step A is finished. And then we actually look up the plan, like the original plan. And the plan tells us, hey, if step A is successful, go ahead and execute the step B. And by the way, step B consumes the result that it was emitted by step A. So then we actually pull that out from DynamoDB, and we actually go ahead and execute step B, which is another Lambda function. And that kind of continues, right? So in a way, we actually built a language that you would program the cloud, like treating the cloud as a computer now.
So I think when you have a simple architecture diagram showing some of the services involved, it might be the perfect segue to move to that.
Sure we can. So yeah, this is kind of the simple diagram. Essentially, if I were to start on the left-hand side, left-hand side are the customer AWS accounts, right? That's what they have. On the right-hand side is everything under Clumio, what we manage, essentially. Now, like I said earlier, from the customer's perspective, everything that we do is a service, and then our footprint is nothing more than an IAM role and a CloudWatch trigger. Basically, customers installs Clumio in their AWS environment, either through deploying a CloudFormation template or Terraform. And what that template does is actually go ahead and create the IAM role and then the event bridge, essentially. The IAM role is for us to actually access, the different APIs. And then the event bridge is actually for us to be able to detect what are the assets that are being created or deleted. Like, for instance, if you create a new EBS volume, then the way I know that you created an extra EBS volume is because I do get an event. So while that CloudFormation template is being created, what we actually go ahead and also do is we actually create an AWS account that is dedicated for that customer. So basically, we have customer A and customer B. And then what we want to do is that we don't want to intermingle the data together. We don't want to mix customer A's data with customer B's data. So what we do is we create an AWS account dedicated for A and another one dedicated for B. And basically, that's kind of the data plane accounts that, with multiple boxes out there. Once all of this is installed, well, there's two things that happens. All that metadata related about all the assets like EBS, RDS, S3, Dynamo, long list, they start getting collected, and we actually push them through different queues, SNS messages, Lambda functions that go ahead and massage those messages, and we actually insert them into a metadata engine that later we use to create the different reports. That being, by the way, if I move the mouse, do you guys see or not?
We can see your pointer, yes.
Yeah.
Okay. So yeah, using the metadata engine, we would actually go ahead and generate the different compliance report or audit reports for that matter, right? So that's kind of on the discovery side of the house. Then once the customer decides to go ahead and protect that data, through the IAM role, we will actually extract the data, process the data that being compressed them, index them, dedupe them, encrypt them. We'll actually store them in DynamoDB table. We actually create indexes using, things like Athena table. And by the way, everything that we do is through a dedicated KMS key and role, again, dedicated for that customer. That's what we call the data plane. And at the same time, we have the control plane. Over here, we don't have any, basically, we only have metadata of metadata, like very basic information that the UI is pointing at. And then from here, basically, this is what the customer sees. And then the workflow engine will actually run on the control plane. And every Lambda function that gets executed is actually a call into a Lambda function in a dedicated, account in that for that customer A. Does that make sense, roughly speaking?
It does make sense. But can you tell us a bit more about the reasoning why there's a dedicated account for each customer?
Yeah. So, well, one is because we're dealing with enterprise data, right? And we've been asked this question over and over, whether, is my data commingle? What is the level of isolations? So then to that end, we said, okay, well, one thing that we can actually go ahead and do is actually dedicate the AWS account. That's one forcing factor. And then whether it is IAM role, KMS keys, we actually dedicate things for that thing, for that customer. And then from there is basically software practices that you use the right IAM role, the right key, that to the point that even if there's a bug in the software, you should be able to basically detect those just because the operations will fail, right? For instance, the Lambda function in customer A will not have an access or will not be able to read data from a bucket from customer B, let's say. There's no way, because it's not configured that way, like, through IAM roles and such. Like, so even if there's a bug, and I would go ahead and trigger the Lambda in customer's B account to actually read from customer A, I won't be able to just do it.
So
this
tenant
kinda-
isolation, that was the real guiding factor here, making sure that was as isolated as possible.
You just want to take every single step possible to make things harder and harder and harder to break.
And you've touched on this, but from a, say, security perspective, what does Clumio have access to in a customer account?
In the customer account on this side of the house, on the
Yes.
left-hand side, right? Yeah, so whatever we do essentially is through that IAM role. So when the customers comes and installs our software, they can choose what data sources they're interested, or to that matter, what type of functionality that they want to install. So for instance, if they opt in just to do the discover, which is kind of monitoring and discovery, then we don't ask permissions to read the data, because we're not doing any backups. Right? We just need the access to the metadata, and that's what we ask for. And then you will actually see in the CloudFormation template, the permissions that we require. Now, if the customer says, hey, I actually want to go ahead and protect the data, which means I do want to let you read the data, and then so that you can, process it and store it away for me, then at that point, that IAM role will have the permissions to actually go ahead and read the data. However, everything that we do is actually either through VPC and S3 VPC endpoints, is encrypted. It depends. So to answer your question, what sort of access? It really depends. We only ask for what we need and not anything more.
But also, since it is a role in the customer account, they control that role, control what access you.
Oh yeah, they can take that role any day, and then we can't do anything.
No, exactly.
But we do have things like drift detections and stuff like that. So if customers were to change that role by mistake, we would know, and then again the workflow will blow up. And then the support team will actually contact them saying, hey, did you change the role? Is it by accident, or is, you really want to do this? So we should be able, we can detect that too.
And most of that's EventBridge then, right? You're just reading an EventBridge feed or EventBridge bus, kind of, yeah.
That's for yeah.
I had a question for you. So you're very event driven today. What if it's not probing too much? I'm just thinking like a scheduled backup, right? Like I want to back up an EC2 instance every night at 9 p.m., for example, right? What kicks that off? I mean, as a Unix guy, I would set up a cron job to kick off a tar script. Just wondering where's the first domino fall, behind the scenes to kind of kick that off for scheduled jobs when the customer's not clicking,
So it's actually very, very complicated. Basically, because it actually goes through policy engine from resource manager. It's a very complex. So every time that I tell them, hey, we're a backup company, people think that it's very simple, but it's actually quite complicated. But to answer your question again, if I actually go back to like the step 0, well, what triggers things? There's a CloudWatch timer that actually fires once in a while. That will actually trigger, different events, where that will eventually trigger an event in the policy engine that would actually go ahead and evaluate the state. So, customer A, policy gold, what's the priority? And then go ahead and evaluate what are the things that is applicable to that policy. Is it now the time that we need to run? If the answer to that is yes, then we actually go ahead and schedule them through the, resource manager. And then the resource manager looks at all of the different jobs that are coming, or tasks, right? And then it goes ahead and does the priority management. Like, hey, this is a VM with silver policy, and there's another VM with the gold policy. Hey, the gold one should go before the silver, right? So then essentially it does all that priority management, and eventually kickstarts the Lambda function that starts that giant tree of, all that stuff that we looked at based on priority. So essentially, yeah, it's a long story. But if you go to the level 0, it's a CloudWatch timer.
And in which account is that located then?
It is in the control plane.
All right.
It is a control plane. I believe it fires every minute. Every minute? Yeah.
All right, so time flies on this show. If you just joined us, this is Building SaaS on AWS with me, Gunnar. I'm joined today by Woon from Clumio and Anthony, my colleague at AWS. And we're looking at how Clumio is building SaaS on AWS. And if you have any questions, pop them into the chat and we'll do our best to answer them. I haven't brought up every question there, but I think we've answered them anyway. So keep the questions coming. But part of the topic for today was operational excellence. So what are some of the main things you do that contribute to operational excellence?
No, so it starts, I would say it starts from the very ground up, having the right foundation, right? Basically, once you're implementing something, it starts from having the proper design in place, where engineers, do have the time to go ahead and design the proper thing. And then when they're designing, they should consider things like how much is going to cost me to run this. Functionality, the how things are work and all that's table stake. Of course, it needs to work. But then outside of that, you need to be able to identify how much it's going to cost you to run this thing. Then you need to tell me whether the design and the code is going to be how testable. Are you going to be able to test this? You're going to be able to answer that. And then you need to be able to answer the question, is it how you're going to support this, right? Because at the end of the day, again, we're selling a service. And then as a developer, you do want to have a design that the support team can efficiently support it. Otherwise, you're going to get called every hour. And that's not fun. You want to be writing code. And if you want to do that, make sure you have all that in place. Once you have that in place in terms of the design, then it's about execution. And then once it comes to the execution, again, go ahead and write the code that is testable and make sure that you have unit tests and functional tests in place. Again, if something fails, you know that you can actually take that one Lambda function and test it in isolation and all together as well, right? But then, make sure that you have all the tests in place. And then have that whole CI/CD pipeline to the point that you can actually automate the whole thing, right? And that's kind of the some of the SaaS excellence, and that's kind of the how to do it, because there's really no other way. If you wanna run a successful service that scales, obviously, again, spending half an hour on every error, it's not gonna scale. Like both your support team will fail, which means the customers will suffer. And then as a developer, you're going to be on constant calls, and that's not fun because you want to be writing code, right? So it's really kind of, a lot of hard work. It's a combination of various factors, I think.
So you mentioned this a couple of times around how you're rolling out updates for individual Lambda functions and so on. Can you walk us through that a bit?
Yep. So I can actually quickly go back here. Again, it's all obfuscated, so I don't know if this will be a Lambda function or not, but let's say it is for the time being. So what happens is, like, let's say that we have a bug out here in this Lambda functions, for instance. Then what happens is that every Lambda functions has a version attached to them. So now if I'm rolling out a new version of it, then it will be a new version. So then it is the workflow that actually, meaning the platform that takes care of all of this. So essentially the entire plan or workflow tree that started before the patch, it will continue with the older Lambda function. But everything that starts after that point, it will actually start using the new Lambda function that it got deployed. Right. And then that's how it's done. And then if there's failures, essentially, it's because messages are kept in the queue. So essentially, we will actually retry them as well. But it's really about, identifying what's in progress, let the stuff that is in progress, to finish. and maybe it will fail. And if it does fail, then we have catches in place in the policy manager that will re-trigger the whole thing. And then when we re-trigger it, obviously we're going to use the new Lambda function. Therefore, it gets patched up automatically that way. And then the new ones will just start executing the new Lambda functions. And then we also have a concurrent task that we actually periodically go and look all the functions that are no longer used. Because let's say I had V1, I pushed V2, but then I had a couple workflow that was previously using V1, right? But then a couple of days later, we will actually scan them through. There's nothing else using that V1. We will actually retire that Lambda function along with the code that implements that, so that you also want to keep the tree clean.
Do you use the AWS Lambda feature of versioning, or do you do your own versioning of Lambda functions? So you're deploying a entirely new AWS Lambda function and pointing towards that?
We today deploy a new Lambda function every time, and then there's we went back and forth, but today we let the workflow deal with that, all that versioning and all that stuff.
And just to double click on something you said earlier, Woon, if I'm a support engineer or a developer and something fails, this is their source of truth, right? This is not, they don't have to go to 2 or 3 different places. That's huge, right?
Yep.
During failure times, and that must have been a lot to build, right? Just to kind of get that in there, right, and not have to look in different spots.
Yep. So it was a lot to build. That's why it took us about 1.5 years to 2 to get this ready. And then what happens, and then you're ready. Then you start building EBS backup, RDS backup, DynamoDB backup, restores, and S3 backups. Now you're building on top of that. Now suddenly you have 10, 20, let's call it workflow applications. But at the end of the day, when an error happens, the support is actually debugging through the same tool. It's the same bubble, triangles, and rhomboids that they look at and debug. So they don't have to learn 20 different things, but it's actually that one thing that and debug. And it's basically, the platform is what takes care of the whole thing. And then, the whole rigor about testing and making sure that, your code coverage is there, that you can roll this out anytime, forward, backward, and all that stuff. Things crashes, you retry them. There's things about idempotency too. Every single one of these steps, there's a Boolean that tells me whether that step is idempotent or not. So for instance, if one Lambda function is executing and it fails, right? It just fails in the middle. And then when it actually restarts, is it safe for me to actually blindly restart the function? Well, if the step is marked as non-idempotent, I can't do that. And at which point we decide to fail instead of kind of blindly restarting. So then essentially, but if the step is marked as idempotent, then I actually go ahead and restart them because it is idempotent. And then the testing framework also makes sure that if it is marked as idempotent, it is idempotent by actually executing multiple times and introducing errors in the middle. So that's basically, it is a lot of work, yes, upfront. The cool thing is it's a lot of work upfront, but once you have that, it pays dividend throughout the time.
And then say you find a bug, you're able to fix that bug. How quickly can you have that new Lambda function in production then?
I would say in the matter of half an hour. Under half an hour, we can have it up. Under half an hour, we can have it up. Now, obviously it takes more than half an hour to fix it, right? Yep. Well, sometimes are very silly bugs that I'm like, oh man, what happened?
But after fixing, half an hour.
Half an hour,
that's pretty awesome.
And then we go ahead and do all type of crazy stuff to actually even catch those type of bugs, like dependencies. This is a graph. We actually check graph dependencies to see whether, like in C again. If I come back, if you use a variable without defining it, the compiler will complain, right? Saying, hey, you're using that variable that you never defined it. Well, same thing. Similar things would happen here, that if you're trying to consume an output that it was never generated, like, step A is supposed to consume the output from step C, but step C never executed or is not on that path. So then we throw an error. So essentially, that's what the platform does. You just have everything ready, and no developer actually introduces bug because they want to. Like each bugs is a bug. So the more the platform does for you, the better.
So looking at this, you have multi-account structure this way. Does that pose any difficulties in what we just talked about with rolling out updates and so on?
Yes, sometimes it does. And then again, it's the job of our cloud engine team. They've done an amazing job, which is, I tell you, Lambda functions, right? One example. There's plenty of examples, but one Lambda function, right? So we have, let's say, hundreds of customers. Now, if I find a bug, I have to update the Lambda, right? But then I need to deploy 200 Lambda functions, right? Because let's say there's 200 accounts, so then every account gets a Lambda functions, right? So then essentially it's a CI/CD pipeline that goes ahead and rolls out those Lambda functions through all of the basically the customer accounts one by one.
And how about some other, if we look at this across regions, right? I mean, where do regions fit into this? Be it control plane, data plane, and whatnot?
Great question. Great question. So coming back to this, so within every customer account, we leverage the region. So essentially, the customers can choose to back up to the same region to basically to avoid egress charges, cross-region charges. So you back up data from US West 2 to US West 2. But then we also give them an option to actually back it up in some other region, let's say East 1. So then essentially within the customer accounts, we will actually leverage the different regions. So then to go back to the original question, then it becomes a little more complicated, right? Because we're talking about Lambda functions per account per region. And then we have SQS in place so that we can actually trigger a specific Lambda functions in that account region. And that IAM role and all that good stuff is actually do that. And we also do all of this provisioning of the customer accounts and stuff like that through CloudFormation template and control tower and stuff like that. So.
And before we started this broadcast, we chatted and well, I'm in Europe, you're in Asia, Woon and Anthony in the US. And as a European, GDPR is something we talk a lot about. Has GDPR been something that you've had to deal with this solution, Woon?
Yeah. So to some extent, we had to deal with it. Because today we operate in the US and Canada. So we do have plans to go to Europe, and in that case, what would happen is that it is data plane accounts essentially that hosts all the users' data and the majority of the metadata. So essentially, that's another level of isolation. Now, again, if you want to back up from Ireland to Ireland, that's cool. And if you want to do out of region backup, you can back up from Ireland to Frankfurt. I don't know. I'm not a GDPR expert, but that's up to the customer.
Yeah, that's the key point. It's all under customer control. It's not something Clumio is doing by default. They would have to initiate that copy if they wanted to. And to use the Ireland to Frankfurt example.
All right, so we are approaching top of the hour, so I think it's time for our wrap up. These hours just fly by as usual. I want to mention that I think it was yesterday, Anthony and Woon, that an episode of This Is My Architecture with Woon and with Clumio was released. So I'm going to post a link to that in the chat. Don't press the link just yet. You want to see the final minutes of the episode, but keep that link and have it with you to watch it afterwards for a more even deeper dive into the actual architecture of how things work. So just briefly walk us through what we touch upon today, Woon.
So essentially it starts, to summarize is really about what the importance of the platform. Why is it so hard to build a SaaS as compared to because what it means is that you're taking the complexity to yourself, so that comes with a cost, and you do have to have the right platform to manage that complexity. Otherwise, you're not going to be able to scale. Like again, I'm going back to the same thing. So the platform is key. Make sure that you actually use the right AWS components to actually go ahead and build it. It's okay that you can iterate later, but make sure that the platform is in place so you can actually iterate quickly. That's pretty much it. I think you go and start and learn. As long as you have the platform to iterate, then you also have a way to go ahead and learn and kind of change things along the way.
And my final question to them, Woon, is, would you do anything different if you were to start from scratch today?
Yeah, because I actually know a lot more now than then, right?
Yeah.
But it's okay. I mean, maybe we took a little bit of a detour to get there. I mean, if I knew what I knew then I would have taken the straight path, but that's okay.
You would end up with the same Clumio in the end?
Not really, right? Because I'm a software engineer. It's a very tough question. I always have things that I would like to do better, to be honest.
Yeah,
but
no, that's always it. Don't want to put you on the spot.
I'm happy where I am, but yes, there are things that I wish I could do better.
Yeah, that's good. All right. So with that, I think it's time to thank Woon and Anthony for joining us today for look at how Clumio is building SaaS on AWS. Thanks to Woon and Anthony. Thanks to all the viewers and for the questions we got. And I hope to see you all again in 2 weeks. Thank you very much.
One last plug. We're hiring. All right. We're hiring in US. We have a site in India, and we're actually starting an R&D center in Korea this year. So if whatever you heard today was interesting and exciting, hit me up in LinkedIn and we can talk about it. I'm done.
Really good. All right. Thank you all. Bye-bye.
Bye.